Okay, we're going to look at calculating the volume of composite objects. And so what that means is basically probably we'll have to do two or more volume calculations. So either it's two objects stacked on each other, touching each other together, or maybe it's an object where something's drilled out of it. So basically just more than one step for these calculations. So if you take a look at the try these, that kind of is the second example I gave, where it's in this case asking what's the 3D object on the outside of this nut. It looks like a nut that you would use for building and securing items. So if you take a look, it's 1, 2, 3, 4, 5, 6. So if we didn't have that middle part drilled out, it would be a whole base of a hexagon and then hexagon on the back. So this is a hexagonal prism. So hexagonal, I'll put the word based prism. And then what's the inside? Well, that is a circle, but it's three-dimensional, right? So it's a circle drilled out all the way through. So it's actually a cylinder. And a cylinder is really, I guess you could call it a circle-based prism, but we never do. It's a cylinder. Okay, now we'll do some calculations. So it says Jesse worked at a jewelry store. One popular metal stud they sell has the dimensions shown. What is the volume of this stud to the nearest cubic millimeter? So basically we assume everything is solid metal. And so it first asks what 3D objects make up the composite object. So take a look here. These two ends are cones. So two cones and one cylinder. Looks like a rectangle there, but think about it, it's not going to be a rectangle. It'll be round, and so that will be a cylinder. Okay, and here we'll assume that these cones are the exact same. They didn't specify, but we're going to assume that because if you line that up, those would be the same. So they'd have this same diameter, okay, there. And then they're not giving you the vertical height, so we're assuming it's the same. So what is the total volume of the objects at the ends? So those cones. So remember the volume for a cone. So this is the volume of a cone is pi r squared times the height divided by 3, or 1/3 pi r squared times height. Same thing. Okay, and so we have two of them. And so now we'll have the two out front. We'll need to put in the radius. So the diameter, as I said, was 5 millimeters. So the radius is 5/2, which is 2.5. That'll end up being squared. And then the vertical height, so these are on its side, but the actual height of the cone is the 6 millimeter. And then we have to divide by 3. Okay, so, oh, I thought I got my calculator out. Just give me a sec here. You can start entering it if you want while I wait for my calculator. Almost there it is. Okay, so So 2 times pi, so basically 2 pi, we don't have to put the times in. And then if you want to use brackets, you don't have to put times, but now I'm going to put multiplied by the radius squared, or you could use exponent 2, and then times by the height, and then divide by 3. Now we don't need brackets around this because we're just dividing by one number. But if you were dividing by something like, I don't know, 3 times pi or 3 times 2, you would have to divide and use brackets. But we don't have to in this case. So we can just do divide by 3. I'm just going to take a look at it, make sure I've got everything in there. And that's going to be 78.5398. 78.5398. I'm not going to round it yet because I'm not done. Then the volume of the object in the middle, that's a cylinder, as we said, so that's pi r squared times the height. And so the radius of that cylinder. So now we have to look here. The diameter of the cylinder is 2. So the radius will be 1. So that's 1 squared, which will be 1. And then the height of the cylinder is actually this length here. It's all on its side, and that's 12. So it's pi times 1 squared, which is just 1, times 12. So really, it's 12 pi. If you wanted to, oops, that's not what I wanted. But you can put it in the same order. Oops, what is going on? You can put it in the same order that's listed there if you would like. So, second. So pi times 1 squared is 1. You can put the squared if you want, times 12. It's 37.6991. 37.6991. Okay, and then what is the total volume? So now you add those together. So 78.5398, 37.6991. And so in your calculator, I already have the last one. So I can just add 78.5398 and 116.2 if I go to 1 decimal place. And to the nearest whole number would be 116. Okay, then just in the reflecting here, it says, what must you do to express the volume of the stud in cubic centimeters? So you would either convert all of these measurements that you've used to centimeters. So they'd be all decimals. And then it would calculate out to centimeters cubed. Or you can look on your formula sheet for, oops, let's just do that. We're looking for area in metric. And so actually, yeah, they don't, sorry, we're doing volume. So here, 1 millimeter cubed is this many meters cubed. And then you would want to go from meters cubed back to centimeters cubed. So actually, it might be better to actually calculate the conversion for millimeters cubed to centimeters cubed. So if you think about this, 1 centimeter is 10 millimeters. So if we cube this, 1 centimeter cubed is 1,000 millimeters cubed. So we would then, if this is millimeters cubed, divide by 1,000 to get it into centimeters cubed. Okay, Next one says Carl works in a wood shop. He needs to make wooden door stops as shown. What is the volume of wood he needs to the nearest cubic inch? This is all in inches. So this is kind of interesting because it's not an exact rectangular prism. It's not an exact triangular prism. You could cut it into parts, or you can think about what a prism is. A prism has two parallel polygons with rectangles that join them. So really, if I look at this front part here, this is a trapezoid. And it's the same trapezoid as on the back side of it. And so this is really a trapezoidal prism. And so if we can find the area of this trapezoid, then we would multiply it by the height if we tip this on its side, which is 1 inch. So it's probably going to give us some space over here. Now it says here what 3D objects make up the doorstop. Okay, so based on what I was just saying, I was saying, okay, well, we could cut it into two parts, or we could use the fact that it's a trapezoid and call it a trapezoid prism and calculate it that way. What the workbook has done is split it into two parts. So we'll do it that way, but just realize that there's more than one way. So if I look at cutting it here and along here, okay, then I've got a rectangular prism. You can see it along, kind of see it now. And then I'll do this one in green. This would be a triangular based prism. There's the triangle there and at the back. And so those are put together. So that's kind of what they're meaning here. So a rectangular prism plus a triangular prism. Okay, and so then what is the volume of each doorstop? Well, of each part of the doorstop. So length times width times height, that's for the rectangular prism. So we need to look back at it. So we've got a length of 2 inches, a width of 1 inch here. It's the same all the way along. 2 times 1 times 3/4. So 2 times 1 times 3/4. Now you might be able to do that in your head, right? That's going to be 6/4, which is 3/2 cubic inches, which is 1.5 if we use decimals. Okay, so then the triangular based prism is the area of the base times the height. Well, the area of the base is a triangle. Okay, and so we've got to find that. So you can see here that they've divided the two over here. It doesn't really matter where. Let's take a look at what we've got here. So we have this horizontal will be 1.5, same as up here. And the height of that is 3/4. Okay, and then the width there is 1. So 1.5, right? So 1.5, and then 3/4 divided by 2 times the 1 in the height. So really, that's 3/2. If I keep this as fractions, 3/2, 3/4 divided by 2 is 3/8 times 1. I kind of want you to practice your fractions here. Okay, and then multiply all of those together, you can see you get 9/16. Now, what is 9/16? If we did do it all in our calculator, that would be 0.5625. 0.5625. And so if we add them together, it's in there plus 1.5 is 2.0625. 2.0625. Then if we round to the nearest cubic inch, they've given you the answer, which is 2. Okay. Plastic pipe is 4 meters long. It has an outside diameter of 5 centimeters and inside diameter of 4 centimeters. What's the volume of the plastic in the pipe? Expressed in cubic meters to the nearest thousandth. Well, I think I'm gonna start with doing centimeters. That's what the workbook has done as well. Centimeters cubed, and then convert to meters cubed. So things to note, the length is 4 meters. So 4 meters, remember, is 100 centimeters. And then this diameter is 5, this outside, and then the inside is 4. And basically, this is a big cylinder where a smaller cylinder is drilled out, if you think about it that way. That's the way we'll think about it in order to calculate the amount of plastic. So we need to take the volume of the whole thing and subtract the volume of the cylinder inside. So that's what it's doing here in the workbook. So you can see it says radius of the outer. So here the radius, well, the diameter is 5, so radius would be 5 over 2, which is 2.5. And then the inside, the diameter is 4, so radius would be 2. So pi times 2.5 squared times the whole length of that cylinder, which is 100 centimeters. And then we're going to subtract pi times 2 squared times 100 centimeters. Oh, not 100 centimeters, sorry, 400 centimeters. Okay, so get out your calculator. You're off. So pi times 2.5 squared times 400. So 7853.9816. 7853.9816. Let me just check that. Yep. Okay, and then pi, oops, that's not what I wanted. Pi times 2 squared times 400. 5026.5482. 5026.58. 5482. 5482. And then subtract those. So if you have a calculator that you can go back and copy them out, do that. Otherwise, you've written down 4 decimal places, which is good. 2827. 2827. Decimal 433. 4 decimal places would be 4. Okay. Now, in terms of cubic meters, so 1 centimeter cubed is how many meters cubed. So if we look at here, remember on your formula sheet, I'll keep it. It has here 1 centimeter cubed, and then it has it to meters cubed. So we can use that. It also has from meters cubed to centimeters cubed, but note that extra 0 that's in there. But we're going from centimeters cubed, so we'll use this. So that's decimal point with 5 zeros and then a 1, because it's 1/1,000,000th. So now we would take our answer. Hopefully it's still in your calculator so that you don't have to worry about rounding. And then multiply it together. Okay, so if we do that in our calculator, I'm just going to multiply 0.12345 and then a 1, enter, and 0.002827. 827. And notice how it's rounded for you. So if we are asked to round to the nearest thousand, that 8 makes the 2 go up to a 3. So that's your answer. Okay. If you didn't have a calculator, you'd know that you would want to move 6 decimal places. So 1, 2, 3, 4, 5, 6. Fill in with zeros, and you get the same thing. Okay. And so that is the end of the lesson. And so now you can do the practice.